usually says, hey, if you want to secure your system, have a completely secure system, do this by your own, but we more or less let it open. And the second thing is usually we also have conflicts of interests. Best example, the telemetry. So if you have something like Windows 10 or Google devices, what they want to get some data to improve their services, to improve their business model. And if they would deactivate this by default, nobody would activate it. So what they are doing is they give you the opportunity as a customer, as a company using their software system to make this more secure by configuring it securely, but they don't do this by default. And the naive solution to this is very simple. We have to configure them securely. But there another problem arises, because if we want to configure them securely, we have to know all the settings, we have to configure securely, and we know the values to which we have to set them to. And there's a pretty forward solution to this. We can use implementation, security configuration guides published by independent agencies, by third parties, for example, the Center for Internet Security or the Defense Information Systems Agency, the DISA. And what they are doing is they provide us with automatic checks for the guides, and they provide us with the guides itself. So what a publisher publishes those guides, and what we can do is to actually the administrator can configure the system based on those guidelines securely. The problem is that we have to configure them usually in a manual way, because these guides are really written for humans, and they are basically checklists for human. And this manual implementation of security configuration guides, it's error prone and it's cumbersome, and this is why nobody is actually doing this on a large scale. And now our paper comes into play, because our solution is we want to automatically implement these security configuration guides, and this is possible with our approach. So let's talk about our approach. So the general idea is that we use the security configuration guides as an input, and in the first step we try to extract all the important information we need to implement. So when I implement, I mean we want to apply those rules on our computer system. And our computer system can be something like a Windows 10 instance or Windows Server or something like that. In the second step, we want to verification. And when I'm talking here about verification, we want to know if the things we have extracted are actually existing. So are these settings existing on the given computer system, and are the values valid for the settings we have extracted them for? And these two steps, so the first step of extraction and the second step of verification, are conceptually the most interesting steps of our approach. This is why I want to talk about them in the next couple of slides, where the last three steps, so the transformation in what's actually happening on the machine. Usually we can set something in the graphical user interface, and something is happening in the deep of the system on some lower level, and we have to do this transformation if we actually want to implement them automatically, and also this transformation to code. So how this is really exported, for example, to get to the system under test, and how the actual implementation works. This is conceptually not that interesting, but we also need this to be able to evaluate our whole approach and to use this in a real life scenario. So let's step back and talk about the extraction. And what we have recognized is that these guides are using very schematic language. And we can use this by writing a grammar. What we are using for natural language processing here is the NLTK, so the Python library for natural language processing. And we can write a grammar with several rules. For example, I have two presented here: sentence with enabled with X selected for. So, and these grammar rules consist of certain patterns. So we start with a preposition we start with a preposition and have arbitrary input. Then a to is followed by some verb form, past tense participle, something like that. Then we have another preposition. We have arbitrary input, again, a verb in past tense or a past participle, and some preposition, some nouns, followed by a dot in the end. Or another rule is that we have a preposition, arbitrary content, a to, some cardinal digit, some noun in plural, coordinating conjunction, some adjective in the comparative, arbitrary content, and a dot. And we can specify those rules and can use the rules to extract the important values we need in the security guide configuration rules. Let's talk about this in an example. So we have this example sentence from an actionable guide. And the sentence is like, configure the policy value for computer configuration and so on and so forth to 15 minutes or greater. So if we use this sentence, give it to NLTK, what NLTK part of speech tagging is giving us is this. So we have here the important information in black and here in 15, in green. And I marked this in the color code with the text presented on the previous lecture, so with the part of speech tags. And to make this more visual, I have here the one of the rules from the previous slide as a non-deterministic state automaton. And here you can say that here you can see that this part of the sentence, so before we get to this Q1 here, then we can stay as long as we want in Q1 and Q2 until we finally go with 2 to Q3, with 15 to Q4, minutes to Q5, or to Q6, greater to Q7, and with the dot to the final state QA. So we can see that this part is matching, or this part is matched by our rule we have defined in the first place. And we can then use this state automaton to actually extract the important information because we know when exactly we can find them. So in this case, the path, and here this 15 as a value. And the astonishing thing is that we only need 11 rules to extract values for all security configuration rules in the benchmark guidelines we used for our evaluation. So we only need to write 11 of these rules and can extract the information. The second step was the verification. So the problem is that in Windows, we have here the group policy settings. We have some path we can follow to a specific setting. And then a setting can be as easy or can have the values enabled, disabled, not configured, but can also be more complicated that we have the main setting, which can have some values, but also subsetting can be configured to specific values. And we have to check if they are actually valid here. So what we do to do this verification is we use the documents, we specify which values are, which settings exist and which values are valid for specific settings, which are in the Windows context, these administrative templates defined in ADMX and ADML file. And in an a priori step, we extract the information we need, for example, about the existing paths and the actually the valid values and the registry which are set, so that we can use this during this on-the-fly verification to verify the extracted values. Another small example, so we have a security configuration rule and we extracted the path not correctly because we missed here the slideshow. So we extracted only to the lock screen, and what our tooling can now do is present several options based on the Liebenstein distance between the extracted path and the potential right paths, and what security or the administrator now only have to do is to see from the list of very good candidates that this is what he or she actually wants to configure, and can copy the value, and this is verified so that he now knows, hey, this is an existing setting and the value is also matched. Or make this with a more complicated example. So we have extracted here the path correctly, but we have not completely correctly extracted the values for this specific setting, because we need here some main setting, and here two, and it's written, because it's written for human, that both options are okay. And this is no existing value, so we cannot implement this or apply this directly. So what we can see here is we have to set the main setting to enabled, and we have to, or we can choose one of these options. In this case, I choose here the selected platform to actually get the correct complete setting, which can then be automatically implemented on the system under test. So I've talked about our approach and the different steps we have within our approach. Let's talk about our evaluation. So in the paper, we defined 5 research questions, and the first 3 research questions are about how many rules can we automatically, or for how many rules can we automatically derive an implementation from the text in natural language. The second was how many of the extracted rules are automatable, and how many rules are how many automated rules are not extracted. So what is our error more or less? And the third question, the research question, was after correcting wrongly extracted automations, how many rules can we actually implement automatically? So this, we did some benchmark evaluation on these first 3 research questions. The 4th research question is not that interesting. That's why I want to focus on the first 3 and the last one, because the last one is how many rules are implemented correctly in accordance with the automated checks. Remember, so we have automated checks because the standard we are considering is defining how to write and how to execute automated checks, but we don't have the automated implementation. And this is why we have here some ground truth to evaluate in the 5th research question, our approach. So when it comes to the first 3 research questions, we took a DISA guide. This DISA guide is for Windows Server 2016, has 274 rules, but only 207 of them are actually with an automated check, because some rules are really, you cannot automatically implement or check them. So we consider these 207 as our 100%, and we, in the first step, can, for 95%, extract configurations values with our 11 rules I have told you before. So for 95%, we can completely, we can extract information for them. And for the second research question, so first time verified are 83%. So for a lot of rules, they are simply with no manual effort, completely verified, and we can completely automatically implement them. For 1%, we extract something which is actually we cannot, which is not automatable. And for 2%, there was something that this is a rule which is automatable, but we did not extract the correct values, and also the verification could not give us something useful there. But in the end, we end up with almost 97% of this guide, which can be automatically implemented. If you want to redo, or if you want to investigate in this, we have provided the, our benchmark on Windows Server 27. And we have done another, we have redone our steps on the DISA Windows Server 2019. And if you want to see how easy, so these are just small scripts we had to do for creating this this guideline, this benchmarks. Here's our repository for reproducing the steps. So let's talk about the 5th research question. And as you can see here, we have taken a lot of guides. We have actually implemented, they have over 2,000 rules, and 2014 have actual automatic checks. And for 97% of them, our tooling, our approach can correctly implement them automatically. And if you want to see the results, here is the next QR code to this. So the discussion, first problem, we can only work on Windows currently, but we are working on Linux, Mac OS, and Android. We can only do this because of the Center for Internet Security and DISA are very schematic in the language. And we are totally aware that this is only an intermediate solution, because the cool thing would be that we have this information included in the guides itself. So, conclusion, we can extract information for 95% of the rules. 80% can be automated with no manual effort. And according to the automatic checks, 97% are correctly implemented. And we hope that in the future, our work can improve the security configuration of Windows dramatically. What we have done is we have moved from this situation where we have some guides published. We can use this, the extraction and the verification presented within our approach to actually get this very decent result. And this would be the end of my talk. Thank you for listening.
Thank you. Very nice presentation. So there are no questions on Whova. Are there any questions from the audience? Can you please raise your hand? Okay, so there are no questions. So I do have one. Okay, so I mean, in your approach, I mean, you mostly covered basically Windows-related guides. So this was basically the goal of your instruction. How easy it will be to extend your approach to cover other security guides?
And this is what we are currently doing. And the main advantage of Windows was that we have this more or less definition of which settings are existing in this ADMX and ADML files. And for Linux, so there are published guides for example, from the Center for Internet Security to harden Ubuntu systems. And the problem there is that it's much more difficult because a lot of these, so in the Windows context, we had these paths and the values for the paths, but now in the Linux context, we have a lot of configuration, which has to be done with some command line commands. And now we are working on how we can actually extract the scripts from these guides, which is the easy part, because usually this is very nicely extractable also with natural language processing. I don't want to call this natural language processing because it's more or less pattern matching. But now the interesting thing is to also have something like this verification step for the Windows, for the Linux guides. And here, what we would have to do is something like, hey, we want to know if this parameter is valid for this command line command, but this is a very cumbersome work because we have actually to check if these parameters are existing. And the further thing what we have, or the next problem with what we want to solve with this with the Unix world, with the Linux world, so to say, is that we want to, what is currently done is that, for example, the Center for Internet Security is publishing a guide on Red Hat Enterprise Linux, and is also publishing a guide on Ubuntu. And there are some things which are similar. There are some things which are actually equal. So the same command line commands you can use on both systems. And what we are currently working on is how we can write these guides in a more modular way, that we don't write a guide for Ubuntu, but for smaller components of Ubuntu, and can use and can then create a Ubuntu guide or a Red Hat Enterprise Linux guide, by getting the modules, getting the security guides for the modules, and maybe you have to apply some Ubuntu specific diff to the actual scripts to make them work on Ubuntu. So we are working on this, but as I said, Windows was more easy to achieve and was also more in the focus of our collaboration partner Siemens, because a lot of business infrastructure is still based on Windows.
Thanks. It was a very exhaustive answer. Okay, so thanks, Patrick. Let's move to the next talk.